All right, folks, welcome back to MrMiers Math Channel. Today in Chapter 7 on radicals and exponents, we're going over Section 7.3, which is solving radical equations. All right, so let's get into it. We've got some general steps to solve radical equations. Step 1 being isolating the radical on one side of the equation if necessary. Step 2, raise each side of the equation to the same power in order to eliminate the radical. And then Step 3, solve from there, and Step 4, check our solution. All right, so when we're dealing with equations with one radical, what we've got to do is first isolate the radical. All right, so we'd solve this basically in general the same way we would solve this equation, x minus 4 equals 0. We'd get x on one side by itself. In this case, we get the radical on one side by itself. So we add 4 as well. And now we're just going to raise each side of the equation to whatever power that would get rid of that radical. Now this is a square root. The index of that radical is 2. So we're going to raise each side of the equation to the second power. So we would get x equals 16. Remember, when we square that square root, that just undoes the square root. So we get x equals 16. Let's check our solution. All right, that means the square root of 16 minus 4 equals 0. The square root of 16 is 4, and 4 minus 4 does equal 0. So that works. All right, in part B, we'll do the same thing. We'll add 2, get the cubed root of x equals 2, and then we want to cube both sides. 2 cubed is 8, so we get x equals 8. And once again, check our solution. And that would be the cubed root of 8 minus 2 equals 0. The cubed root of 8 is 2. So we get 2 minus 2 equals 0, which is true. Awesome sauce. Moving on. Now, in example 2, part A, the first thing we would do is subtract 3. And some of you might be worrying about this negative 3 here, but this is okay. The cubed root of x equals negative 3. What we've got to do is get rid of that radical, so cube both sides. And when we cube the right side, we're cubing that whole thing. So I'm going to put it in parentheses. That way, it's the same way that you type it into your calculator. In this case, it makes no difference, but in other cases, it would. We get x equals negative 27. And once again, if we checked our solution, this one would work. All right, in part B, we'd add 5 on both sides. We get the square root of the quantity 2x equals 8. And then we would want to square both sides. So we get 2x equals 64. And divide by 2. And we get x equals 32. Awesome. Let's clear the board and move on. Let's go over one more of this type, and let's make that part D. So we're going to skip C, move on to D. All right, in this case, I know there's a lot of stuff going on. One way we can think about this is let's just call this like a variable. So I'm just going to say like 4y minus 12 equals 0. So what we want to do is isolate the radical, and let's call the radical y. So the first thing that we would do is add 12. So we get 4 times the 4th root of 8x plus 9 equals 12. And then after that, we would divide by 4. And that just isolated the radical. So we get the 4th root of the quantity 8x plus 9 equals 3. And then we're going to raise that to the 4th power on both sides. So we get 8x plus 9 equals 81. Subtract 9. 8x equals 72. Divide by 8. And we get x equals 9. All right, so it's the same kind of steps that we would use to solve a simple equation there. All right, now moving on to equations with two radicals. So to solve equations with two radicals, we want to first rewrite the equation so that each side has only one radical, so one radical on each side. Then raise each side of the equation to the same power that would get rid of those radicals, and then just solve from there and check for extraneous solutions. All right, so we already have that first step done. Okay, and now the second step is raise each side to that power that would get rid of the radicals. Now what's happening here is it's just eliminating the radical. So what we have left, the argument is still there. So we have 2x minus 5 equals 10 minus x, and then we're going to solve that equation. So we could add x, add 5, and we get 3x equals 15, and x equals 5. And then we'd want to check our solution, because in some of these we would have extraneous solutions. So if we plug 5 in, we'd get 10 minus 5, which is 5 on the left side. So we get root 5, or square root of 5 on the left side, then 10 minus 5, square root of 5 on the right side. So this works. Okay, we're actually going to skip part B, and we're going to move on to part C. Now in this case, we have the cubed root of both of these, and we have one radical on each side, so we could just start by raising it to that power. That's going to get rid of the radical. Once we do that, we have x plus 6 equals 2x minus 7, and then solve from there. So we could subtract x, add 7, and we get x equals 13. And this does in fact work if we plug it back in. All right, so in talking about extraneous solutions, raising each side of an equation to the same power can lead to solutions that don't make the original equation true. So an extraneous solution is a solution that we get mathematically, but when we plug it back in, it doesn't make any sense in the context of the problem or the original equation. It doesn't make that original equation true. All right, so that solution, that is an apparent solution, is actually not a solution. All right, so let's move on and let's check this out. So in this case, we have a radical. It's on one side, so let's eliminate that radical. What we're going to do is raise it to the power that's going to get rid of it. If we do that to the right side, we got to do it to the left side. And that's going to give us x squared equals x plus 6. Now this is quadratic, so we would want to get everything over to one side and see if this thing is factorable. So subtract x and subtract 6, and then factor if we can. This is factorable, so we get x minus 3 times x plus 2 equals 0. And if we set each one of these equal to 0 and we solve, set each factor equal to 0 and we solve, we get 3 and negative 2. All right, in this case, one of these doesn't work. All right, let's plug 3 in. If we plug 3 in, we get 3 equals the square root of 9. And 3 does equal the square root of 9. The square root of 9 is 3. If we plug negative 2 in, negative 2 plus 6 is 4. And the square root of 4 is 2, but not negative 2. So negative 2 is an extraneous solution. So the only solution in this case would be positive 3. All right, let's move on to the last one. In this final problem here, like the last one, we have a radical on one side, so let's eliminate that radical. So we'd get x squared equals negative 4x minus 4. Let's get everything over to one side. And let's factor. All right, this is a perfect square trinomial. And it factors to be x plus 2 squared. All right, so we want to set each factor equal to 0 and solve. In this case, the factors are the same. So when we solve this, we get x equals negative 2. And let's plug it in to double check. Negative 2 times negative 4 is 8. 8 minus 4 is 4. And the square root of 4 is 2. But 2 doesn't equal negative 2. In this case, we have no solution. All right, the apparent solution that works actually doesn't when we plug it back into the original equation. All right, folks, so that's it. If you enjoyed this, please like, subscribe, and share. Thank you, and have a great day.